for Physics 2 Lab 2. The purpose of this lab is to find the electric force on the upper tape by the lower tape and the charge of each tape using the distributed charges model. Principles I used were the electric force field, superposition, and the second law of motion. As a preview of my results, I found a value for the magnitude of charge on the tape that was different than what was found with the point charge model. The first physics principle I used was electric field, which is the force per unit charge due to the electric and magnetic field of a charge, shown by the equation below. I used this so I could find the electric force for each point charge, and the electric force is the force on a charge due to the field of another charge, given by the equation below. With the electric forces that I found for each point charge, I could use superposition, or the summation of forces or fields on a point, which is equal to the force or field at that point. So I could find the net overall electric field for the upper piece of tape. And same with the force. I also used the second law of motion, which states the net force equals the mass of an object times its acceleration, to show how for no net force there should be no acceleration, allowing me to show that the electric force should be the same as gravitational force. I used a modified Python code for the distributed charges model, and the system was the upper tape, the surroundings were the lower tape and Earth. And the code that I used had initial conditions that were derived from my first lab to calculate the electric force on the upper tape by the lower tape. I had to change the charge value Q manually through trial and error until the net force equaled 0, because with my initial conditions from lab 1, the electric force was too low. I had also modeled the electric force and field of the lower tape on the upper tape as a line of point charges interacting with another line of point charges, with the number of point charges being 50 for each line. I iterated through each point charge on the top and bottom with a nested for loop to find the total electric force on the top tape. This is the code that I used. The upper left shows my initial conditions that I found from the first physics lab, with the exception of the charge Q, which I had to find through trial and error. To the right of that is the function for finding the electric field of a point charge on another point charge. And I used that in the bottom box of code, which shows the for loop that found and summed all of the electric forces for each point charge. This is the graphical output for the code, and as you can see, the magnitude of the electric force is equal to the magnitude of the gravitational force, just in two different directions. And the little green arrows are the individual electric forces for each point charge on the top tape. I had to modify the charge of one piece of tape input to get the net force to equal 0. I couldn't just use the initial conditions found from lab 1. And the magnitude of the charge on each piece of tape found by the distributed charges model was 2.44 times 10 to the negative 8th coulombs. And the magnitude of the electric force was 1.66774 times 10 to the negative 3 newtons, and about the same for the gravitational force on the upper tape. The magnitude of the charge on one piece of tape, as calculated by the model, was what I said, 2.44 times 10 to the negative 8th coulombs. And an assumption that I made to determine the charge was that each tape had the same amount of charge evenly distributed along the length of the tape. Sources of error include inaccurate lab 1 inputs from code that could be potentially incorrect. And additional to that, the model inaccurately assumed the tapes had an evenly distributed charge, which they likely did not, because the tapes were likely charged more in some areas than not. And the total electric force was dependent on the number of modeled point charges on each tape, or the n number, and a higher n likely would give a more accurate model. Single point charge, and this will change the estimated charge of each tape. Compared to the single point charge model, the line of point charge model had a higher estimated charge, seen by the numbers below. The lab 2 value was 82.8% higher. It's different because the distributed point charge model is more precise, using smaller step lengths to calculate the electric force. the distributed charges are more likely to be closer to the real value due to the increased precision and higher similarity to the original experiments.